Hello everyone. I know this is the video you've all been waiting for. It's going to be so exciting because we're in 10.2 and we are going to conduct some hypothesis tests. In this case, only for the parameter of proportion. We're going to talk about means a little bit later. That's going to be in 10.3. But for now, we're just going to rapid fire do some examples. I think there's about 4 examples in here. And why don't we just get started? If you'll just bear with me, this is maybe a long video to do 4 examples, I don't know. But here's the name of the game. We have such a nice calculator button that we will use for doing the hypothesis test for proportions. It's going to be one prop z test. Just like we always saw before, proportions go with z, and in this case, test. Hopefully this button will be easy to find whenever you're looking for it because one proportions go with z, and we're doing a hypothesis test. The button itself, the name of it, kind of is self-explanatory. But anyways, why don't we get some practice using it? So for this example, it says a marketing manager for a cell phone company claims that more than 35% of all children aged 10 to 11 have cell phones. In a survey of 5,000 children, we're assuming that this survey, of course, is done by some type of an appropriate random sampling method. We found out through this survey that 1,805 of them had cell phones. We want to test the manager's claim using a significance level of 0.01. So, of course, the claim is that more than 35% of all children, blah, blah, blah. So the proportion is more than 35%. That's the claim. So of course that should be the alternative hypothesis. The null hypothesis will be the same. We will just substitute equals for the greater than. In this case, we have alpha level of 0.01. And we need to know the critical value for that one because that's the next thing to do is to find, of course, the critical value there. Critical value for 0.01, do you remember it? It's going to be, I would just find it real quickly. It must be in the 2 range, 2 point something, the area of 0.01 to the left. That's the critical value that's going to go. But we're looking for, in this case, it's greater than. So this is a right-tailed test. Right-tailed means that the critical value, it should be the positive one. It should be the one that's on the right side. So it should be the positive 2.33. Why don't we just call it there? The test statistic in this case is the z-score, which in this case, we're going to need to find a lot of things for this one to find the proper test statistic, but why don't we just see what this button is going to do for us? If we go into here and find stat, tests, and then one prop z test, it looks so promising for us because P naught, by the way, that's always the number that's here. P naught is the number 0.35. It's the number from the claim. In this case, we want it to be, what did I just do there? It should be 0.35, of course. In this one, 0.35. And then X, this is the number from the survey, which is the number of kids that had cell phones since we're testing that proportion. So that's the number that goes 1805. And then N should be the sample size, which the survey had 5,000 students. And we are testing whether the proportion actually is greater than 0.35. So we would choose the greater. Now let's calculate this one. And it actually will give us, by the way, do you see it, the z value right here? It goes through all of the mumbo jumbo in order to calculate this one for us because we were going to have to find the standard deviation of this and all of those kinds of things. Here we are pretty well set up. The z-score is 1.63. That's the z-score for you see the point estimate is 0.361. We're comparing that against the P naught, which was 0.35. So here from our survey, we got 36%. We're testing whether it's greater than the 35%. Let's get going with a very nice picture here. This is all z-scores, of course, because we're talking about proportion, and the mean of z-scores always is 0. Standard deviation is 1. And here goes 2.33. This is supposed to be 1, 2, and then 2.33. If 3 is here, then maybe it's like here. This is the critical region. And our test statistic is 1.63, which is maybe here. This is 1.63. That's our test statistic. You see that it falls outside of the critical area. So that's good. The p-value is this one that just is called p. Don't confuse that with proportion. This means probability. And I'm kind of getting, my picture got in the way. The p-value in this case is 0.051. And we're comparing that against, of course, the level of significance. This is more than the significance, which was, we were using only 0.01 level of significance. So if we're going based on a classical approach, we would say, hey, look, our test statistic is not inside of the critical region, so we would not like to reject the null hypothesis. If we're going from the p-value perspective, we would say, hey, look, the probability to get that statistic is more than the level of significance, so we would not like to reject the null hypothesis in that case. Either way, we do not reject. So we would conclude that there is basically not well, in this case, we would say not sufficient evidence. There's not sufficient evidence to conclude, or else that should be here. We're going for the template. Can you guys help me out to remember the template for how to phrase this one? There is not sufficient evidence to reject the claim. Should we go with that? What was our claim to begin with? The claim was that more than 35% of all children aged 10 to 11 have cell phones. So if we go and look for we're in the not reject, there's not sufficient evidence to conclude that more than 35% of all children aged 10 to 11 have cell phones. I would like to write that sentence. There's not sufficient evidence to conclude that more, oops, that's not a nice T, that more than 35%, and you can finish this one, 35% of children aged 10 to 11 have cell phones. And that would do it for example number 1. Since this example took a little while, I'm going to break this video up into a few more videos. Maybe we'll try to just rapid fire the other examples into the next video. But this is how we would do a hypothesis test. You see that it's pretty much a no-brainer once you're using the calculator for it. And all of these steps, it seems like a lot having 7 steps that we need to do, but they really come pretty quickly. And so thanks for watching this video. Be looking for the next one where we will do more examples.